Okay. All right. Let us officially get the show on the road. I would love somebody to give me, even if you can't get to 24, I would love you to get as close to 24 as you can and put it in the chat. So let's see, what numbers can I use? 2 plus 3 is 5. And then 5 times 4 is 20. And then 20 plus 8 is 28. So who can get closer to 24 than me? Oh, any newbies in the house? Yes, let's welcome any newbies. Hi, Tyrese. Hi, Nomvohameseta. Not sure I quite got that well, perfect, but I'll keep trying. Anybody get closer to 24? I saw Natasha's hand there. Natasha, do you have the answer?
Hi, no, I was just saying I'm new.
Oh, welcome, Natasha. It is good to have you with us. What I love to do this every so often. Maybe everyone can do it again. Put in the chat. So I'm waiting for your answers on 24, but just put in the chat where you're from in the country. I'd love to know where you are. I'm in Cape Town, in a place called Fishhook, but you don't need to be that specific. I just want to know roughly where you guys are in the country. I know I've asked this before, but I just find it so interesting that my classroom now draws from the whole of South Africa. And then also, while we're doing that, anybody got the answer for this? Okay, so lots of Cape Town, Northwest. I love it. Yeah.
Sorry, I think I spoke over someone there. My apologies. But for those of you who don't know me, my name is Anya, or Ma'am, or Miss V. I go by many names.
Yes.
I'm Sir's assistant in this lesson. So Sir will be taking you through this lesson, and I'm kind of on the sideline reading the chat. Oh, I see Khalid's from PE. I'm also from Gqeberha, in Cape Town. But I'll be checking the chat as well if you guys have any questions or so. So if you're too shy to unmute yourself, please. I am in the chat. I was also a maths teacher, so I can help. All right, back to you.
Thanks so much. Yeah, so my name's Peter, or Sir. I'm the maths teacher, running this, but me and Anya kind of work as a team. So Anya tends to keep an eye on the chat. So please, when you ask questions, look, because she'll be answering. And then, yeah, we're just basically working on this together. And it's great to have you with us. Okay, Kitty Bona, let's have a look. 3 times 2 is 6, and 8 minus 4 is 4. You have got it. You have smashed it. Well done. So let's just make sure that we note that down if everyone wants to see. So 3 times 2 is 6, and then 8 minus 4 is 4. So we've used up all the 4 numbers, and now we just go 6 times 4 is 24. And that is the answer. Okay, so welcome to everyone. It is really great to have some newbies with us. It's great to have people returning. Let us begin the lesson in terms of kind of the structure of today. There's not really too many admin announcements other than if you're in the 2nd week of your free trial, your parents or guardians, whoever signed you up, will get a message from us kind of explaining where things go to after the free trial. And so if you've enjoyed the experience with Watobe, it's really important that you do let your parents know so that they don't feel like they're being spammed, because Watobe will then invite them to kind of sort of sign up for, I think it's a monthly payment, and I think, or 75 Rand a week, or 300 Rand a month. And so you do get a message after 2 weeks kind of around that. Now, if your parents don't know that you're doing this, or they don't know you're enjoying it, that probably would confuse them. So please do let them know. But basically, that's just, everybody has a 2-week trial to assess whether or not this classroom works for them. And we encourage you to tell your friends, because I know, having been a math teacher for many years, many people struggle. And at the end of the school day, they're often really tired. And so they may find that this format works well for them. So please do tell your friends. There's not really any risk, because you can be here for 2 weeks. And then after you decide if it works for you, that's only when you would need to pay. So So there's some wonderful singing in the background, but I just encourage you. One of our things is to put yourself on mute initially. We use our chat stream mainly for interaction. And then every now and again, we ask for hands to go up, and we do hear voices. But for initially, we found as the group gets really big, the best way is to use the chat. And I've got the chat in front of me. Miss Anya's looking at the chat. And so just, don't be afraid to keep an eye on the chat. Miss Anya will be there like a bear, chop, chop. Okay. Now, what are we doing? Because some of you haven't been here. So we've actually been doing lessons on circles. And then also what we've been doing is circle geometry is a grade 11 topic, but it's supported by geometry from grade 9 and grade 10. And so the geometry of lines and triangles and quadrilaterals also comes up. And so we've just been doing a little bit of revision around some of those things. We also spoke about a vocab around a circle. So in a circle, we get different types of things. Many people knew about the center of a circle, but lots of people didn't know about fancy things like chords or tangents. And so if you are new, those videos are recorded on YouTube. And so you can look at them or just go to the Watobe website and everything is there for you to view. Okay, so let's get into where we were in the last lesson. We were doing a bit of recapping, and I want to start with some multiple choice questions. And I also want to talk to you about reasons. So when you make geometric arguments, you'll often find that you have to provide reasons. And so these are some of the official reasons that kind of you use at the end of matric. Now, I'm not going to obsess about reasons, but it is important that you start to get these into your head. So for example, angles on a straight line, angles around a point, or angles in a revolution.
Sorry, sir.
Yeah.
Okay, just zoom in a bit, please. Thank you.
Okay. So these are some of the reasons that you need to start to get familiar with. But I'm not going to obsess about them at this stage, but in the later lessons, in lessons sort of 7, 8, and 9, reasons are going to be much more in focus. But for now, we're focusing on just the shapes themselves. Okay, so we are going to do one question together to warm us up. I want you to choose the correct answer. So it says, you need to select the correct answer and suitable reason for X. So we are trying to find the size of this angle X, and I want you to vote in the chat. Do you think it's 3A, 3B, or 3C? I know that this is, we're kind of warming up again. We're getting our brains going. All right. So you're correct. In fact, it even says correct. All right. So the answer for this is these are corresponding angles. And so that is the relationship that you need to know about. And there are parallel lines over here that mean that those angles will be equal. Okay. And that's sort of grade 9, grade 10 stuff, but it's important to be aware of. If I want the answer for this one, what is the answer going to be for 4? So again, I'm looking for this angle. What's the size of that angle going to be? And what is the correct reason to use? So where is X? If we look at these two, what we have, okay, you guys have all got it. And I actually see that in this particular question, we've got it already. So the answer is C. These two angles together must add up to 124. And so C will be the correct answer. And the relationship is co-interior angles. Let me see if I've got, They all have the answer in already. Okay. I'm going to ask you to find in 6. I want you to find the answer to 6. I want you to put it in the chat. What is x equal to? And what is the correct reason for x? So x equals something. And what is the correct? Pop your answer in the chat there. So, yep, x is 65. And the reason? What is it going to be? Yeah, the sum of the angles in a triangle. Yeah. So if we go back to the official guideline from Matric, let's have a look. Cool. Oh, here's a little thing on the side here. So probably the best way to write it is to write it like this. Sum of angles in a triangle. Okay. What about 7? Can you guys do number 7? What is x going to be equal to in number 7? And what is the correct reason for using this theorem? Yeah, Ms. Anya is also explaining some extra stuff on the side there, but let's try and do number 7. What is x going to be equal to in number 7? Because these are theorems that are going to come up a couple of times in the section. I just want to make sure you're all on the right train of thought. What is this guy out here going to be? What is this x out here? And what is the reason we use when we solve for it? I agree, Mbali. I agree, Aseko. It's 150 degrees. What is the reason? I agree, Mark. What is the reason that goes with that? Yes. So you go exterior angle. Now the fancy symbol for angle is just a symbol like that of triangle. You want to get into your brain the quickest and most efficient way of writing these reasons. So this is the exterior angle of a triangle theorem. And it says that this angle over here is equal to the 2 interior ones over here. Okay, perfect. Okay. I want you to solve for x in this question. What do we have? We've got, don't want to put that, oh no, that's already given away, isn't it? Oh, you know what? I didn't actually, let's move on. I think that is enough on that one. I'll move this thing, the Zoom thing. I want you select the correct answer by solving for x. No, I don't want that one. I want this one. Okay, let's do number 10. A little bit harder. So number 10 is this question here. And I want you to try and figure out what this angle x is over here. I'll try and make this a bit bigger. So
yeah, I was about to say, so I'm wearing my contact lenses and I can't even see. Thank you.
How is that?
It's an adjustment, yeah, but this, yeah, sorry, I meant, yeah, this is good. The kids should be able to see this, yeah.
Perfect. So I want us to try and not just work out what x is, but what little, there's a couple of ways we could do this, but I just want to make sure that we have these skills because they're going to be coming up every now and again in circle geometry. And a lot of students, because the last 2 years have been so affected by COVID, you might have a few gaps in your knowledge. So I want to point out that there are parallel lines, which could be important. And there are also intersecting lines and triangles as you try to find what x is. So I'll give you a bit of time. I'm going to give you 2 minutes to do it. And I want to see those answers being locked in. While we wait for everyone to work on that, I just want to welcome many more of you. Sibusiso, Aseko, Clemela, Apiwe, to Jared, to Nez. Welcome, guys. It is really good to have you with us. And there's a couple of ways to get there, but one of the things is this lonely 70 down here. We need to somehow connect that up. And one of the things that I was thinking was, isn't there a theorem that deals with the relationship between here and here? I feel like that could be helpful. And isn't there also a theorem that deals, well, that's the same one that deals with the relationship between here and here? So this is one way of doing it. And then isn't there one that we just spoke about where this is the X is the exterior angle? So for me, this thing over here has to be 70 because of vertically opposite angles, and this has to be 80. So that's this angle and this angle. And now this X to me looks like it's the exterior angle of the triangle, which means that X must be 150 degrees. Now, I'm not going to do the full write-up, but what I would have had to have done is said that angle YBG is 70, and then angle GYB is 80, and then I would have used the reason exterior angle of a triangle as the last step, and then vertically opposite to get us there. But the answer is indeed 150. So I see a couple of students I've lost you, so let's just slow down a little bit. So if I look at this drawing, that's not the only way you would get there. You could get there in another way. So let's see, but I should get the same answer. So what do I have? I've got, if that's 70, because they're vertically opposite angles, they're like this. Whenever we have this shape, you always get these pairs of angles. Now, some of you might have done, what else could you have done? I don't know if there is an easier way to do it. So that's 70, that's 80. Some of you might have said, okay, well, this is 30. And then angles on a straight line mean that this has to be 150. So these are the properties of triangles and straight lines from grade 9 and 10 that we use as a foundation in circle geometry. Are there any questions about this? Or just give us a thumbs up if you feel like you understand how I got that. Thumbs down if you feel very unsure. I just want to get a sense of what I'm dealing with. Because this is just a little bit of a warm-up to remember grade 9 and 10. But if we don't get it, it is important that we consolidate it now. Okay, let's do these 3 questions. So I'll do the first one, and then you guys are gonna go ahead and do it. So in this question, it's a particular type of triangle. These 2 sides are equal, and we call this an isosceles triangle. So, and in isosceles triangles, the angles opposite the equal sides are always equal themselves. They're called the base angles. And so question A's answer is going to be X is 68 degrees. Okay, and that's kind of what we're interested in. And then the reason would be angles opposite equal sides. Now, these are the angles we're talking about. This angle is opposite that side, and this angle is opposite this side. Sometimes people call these base angles equal, but the official reason in the metric book is that. Using that idea, can you try and find X and Y for me in question B, and find X, Y, and Z in question C? So I want you to put in your books, like I want you to do it, and then when you get the answer, put B, X equals, Y equals, and then for C, X equals, Y equals, Z equals. And we'll talk about the reasons as well, but that's what I want you to try and do, and I'm going to zoom in so that you all can see as much as possible. Ms. Anya, are you happy? Are we zoomed to an appropriate level?
Yeah, I think that's fine. If there's anyone in the chat that can't see them, must let me know, but on my side, it's fine, sir.
Perfect. These look a bit like cat's whiskers, but what they're telling you is that this side is equal to this side. Now, how does that help us figure out what x is and what y is? I'll give you some time to do that. And the same thing down here. How does this help us figure out what x, y, and z are? Well, I think x must be 34 degrees because of angles opposite. Okay, I'm running out of space here, but angles opposite equal sides. Basically, they're both opposite those two cat's whisker looking things, or those two, these things over here. So we know that this and this are going to be the same. Now, if we know x is 34, how do we find y? Well, I think these all have to add up to 100. So those two are equal, but then this one is going to be different. You can see it's actually bigger. Well, there's like an unhappy face there. But the question is, these have to add up to 180. And so you're going to go 180 minus 34. And the reason is going to be sum of angles in triangle. Excuse my messy writing, which should be 68. So 112. And I see that Sibosiso agrees with me. I see Tyrese agrees with me. And I think we're all pretty much on the right track. So let us see if we can do C. I'll wait for the answers for C. I think you need a bit more time. How do we figure out these three unknowns using the theorems of that? Suzanne, if you could go ahead and ask a question. I do see that you have your hand up.
Excuse me, sir. For number B's X question, like for the reason, can you ever say isosceles triangle, or does it have to be angles opposite equal sides?
Oh, the great debate about reasons. Oh, this is such a big thing, isn't it? Okay. Look, I would say go with the official reasons that are given in the matric guideline booklet, which is what I'm showing you now. I mean, it's always a debate amongst teachers. I don't think they will necessarily deduct marks at school, but they may at the end of matric. And so I would say try and train yourself to get into the habit of using these official reasons. You're not wrong to write isosceles. I mean, I wouldn't mark you wrong, but I know some teachers who would. And so I would say try and train yourself to use the official ones from the matric handbook.
Thank you, sir.
Okay. Let's have a look at my answers in my chat going on. So we have X. Aseko has told us X is 54 degrees. And I would say that the reason would be angles on a straight line or supplementary angles. And I agree with you. I would then say that, let's have a look. Anybody else's answers coming through? Let's have a look. So if we know this is 54, then Y must also be 54. And that's going to be angles opposite equal sides. And then Z is going to have to be the 108 minus, no, not 108, 180 minus 54 minus 54. Now I think that's 108, which leaves me with 72. And the reason would be sum of angles in a triangle. Kiribona, you're on the money. Tyrese, you are on the money. Now, guys, I'm worried I'm going a little bit too fast. So give me a thumbs up if you think the pacing is good. Give me a thumbs down if you think the pacing is not great. I just want to get a feel for the group. Okay. Now, obviously, I won't make everyone happy, but what I can say is Miss Anu is going to be manning the chat, and I think I'm going to move on based on what I'm seeing so far. But Miss Anu will keep interacting with you and giving you prompts in the chat. So please don't be discouraged if I'm moving on at this stage. Let's see. Okay, we're just going to do number D, and then we're going to move on. I know it's a bit wonky there. Can you solve for X and Y in question D, please? See what we can do there. So a little bit trickier. Okay, so Nosisa and Boitemelo, have a look at the chat now, and yeah, have a look at, and Mr. Anya is going to come along and try and assist you as best you can. The rest of us, we're trying to get, okay, Natasha also, all right. Is it question C? Okay, let's do what, can everybody, let's just see if I can include both questions. I can see quite a few of you need some help with C. Okay, so let me go. So if you look at this, the first thing you need to do with C, so everybody who's comfortable, go on to D. I'm going to explain C, and Ms. Anya is responding in the chat. This angle over here adds up to 180 degrees. And so we know that this must be 54, or we could say 180 minus 126. Once we've got that angle is 54, so once we know that's 54, we know that this thing over here, excuse the massive red, is an isosceles triangle. And so we know that this is 54 over here, which helps us know what X and Y are. So that's how I knew up here that this was 54 and that was 54. Now the only thing that's left is, how do I get this? And I just go 180 minus these two.
Sir?
Yeah.
May I jump in here? Just something also to assist students, you know, geometry. I actually personally love geometry because there's so many ways you can approach it, but especially for those of you who find this struggling, if, for instance, if you look at number C, you need to calculate for X, for Y, and then for Z. Use that alphabetical order as kind of like a hint. So what ma'am is actually trying to say is, if you can't find Z and Y, or you don't know how to get it, first start with X. That's like a hint. Or if you have a triangle and there's like an ABC or an MNO, try to work alphabetically, because 9 out of 10 times, not always, but 9 out of 10 times, that's like a hint for you to show you where you must start. So same with number D. I'm not going to say anything, but like there's an X and there's a Y. And it doesn't always work like that, but that gives you a hint of where you can start. All right, yeah. Back to you, sir.
Okay, so I'm going to, because we're about halfway through the lesson, so I'm going to move on from this right now. But I think what I thought was, I just wanted to highlight how important triangles are, because even in circle geometry, you're going to see that triangles pop up inside the circles. And so these ideas need to be consolidated. And so in the first one, or in D, what I started by doing was realizing that this is an isosceles triangle, and so that these two angles must be equal, X and X. But then if I add up all three of them, they must add up to 180. So and then I must put the reasons that I do with that. Then I solved for X, and I realized that this thing over here was 70. So X is 70. Now, angles on a straight line always add up to 180. And so Y will just be 180 minus 70, which is 110. And the reason would be angles on a straight line or supplementary angles. So if you feel like you are not comfortable with triangles, I would recommend some extra practice around triangles as you try to build up your knowledge around circles, which I promise you, you'll see triangles keep popping up everywhere. Quadrilaterals and triangles will pop up in circle geometry. It's not just circles we will deal with. Okay, but that was done pretty well. And I think the exercise has been pretty rewarding on the whole. And so what I want to do now is I want to go to my main kind of new content for the day. And I'm trying something new. So let's see if I can do, if it actually works. I've tried to embed something in my little workbook, which probably isn't going to work now. Okay, well, let's have a look here. All right. So here is a lovely circle, which is the topic of this unit. And what you'll notice is what type of triangle is formed in a circle if you have two radii? What is the word for this type of triangle? I'll wait for your expressions of interest in the chat. What type of triangle do I get if I have two radii that meet at the circumference and then I connect them with a chord? So that's the fancy word for this thing over here. So let's see if I can get, oh, I can even draw over it. How fantastic is that? If I go here, this is called a chord. And then these things are, let's see if I can get there. This is the radii. What type of triangle is this? Exactly, it's isosceles. And look at this. Let's say I want to enlarge or shrink my circle or move it around. You'll notice that this isosceles triangle, the angles are always going to be equal. So whenever we have a triangle inside a circle where two sides of the triangle are radii, we have an isosceles triangle where two sides are equal because they're radii and the two base angles are equal. So this is quite an important. And the other thing that we spoke about in previous lessons was that this chord that is going, that's making an angle at the center. So let me actually draw it above here. In previous lessons, we spoke about this idea that a chord could make an angle at the center, but it can also make an angle or subtend an angle at the circumference. And so I want to explore that a little bit now. Let's see what I can do here. And then we're going to do some questions about this idea. Okay. If you look at, let me get rid of the, nope, I didn't want that. There we go. Okay, I have a circle in front of me. Now I no longer have a triangle. What I have is basically I suppose it's like a arrowhead. But what you'll notice is that I have, if I think about the arc CD, now these are all words that we've used in previous lessons. If it's your first day, you'll be a little bit like, need some catching up. The red thing is called an arc. Now, if we connected C and D with a straight line, it would be called a chord. Now, if we take the angle at the center and I tick that, you'll see that the angle at the center is 100 degrees at the moment. Now, if I wanted to, I could even work out what the two angles are in the triangle ACD, but for now, we don't worry. Do you think the angle E is bigger or do you think the angle E is smaller than A? Please put in the chat. So the question is the angle E bigger than A or is it smaller than A? I want to see what you guys think. What does it look like visually? So Bokang and Kiribona have said they've locked their answer in. Nasisa has locked it in. Smaller, smaller, smaller. Okay, so all of you have noticed angle E just looks smaller. It's not as wide as angle A. However, if I move the point E on the circle, if I move it around, do you think E will stay smaller? Or do you think E will be bigger than A? So if I move E around the circle, do you think E will stay smaller? Or do you think it'll get bigger than A? It's a bit of a confusing question. What I'm saying is, if I start to move this point now, will the angle stay smaller or will it get bigger? Let's have a look. Stay smaller. Aha, you guys, okay, let's see. Look at this, guys. I think you're onto something. It doesn't seem, if you look at this angle moving, it doesn't seem to change, right? So I want to put this here and I want you to notice, what do you notice about the, okay, if I move this, it can change, but then the angle at the center changes too. So let's move it back to 100. What do you notice about the relationship between the angle at the center and the angle at the circumference? What do you think? Give it a guess. E is half of A, yeah. And look, if I move, let's say I make the angle, let's say I move the point D. If I move the point D, look how I'm making the angle A much bigger. Is the relationship between A and E staying the same? Yes. So the angle at the circumference is half the angle at the center. And this is an important idea in circle geometry, that whenever we have a circle, the angle at the center will be half the angle at the circumference. Let's play around with this. What other shapes do you think we can get? Oh my goodness, look at this strange looking shape. And what you see is that the relationship is still angle at center is double the angle at the circumference. What other shapes could we make? Maybe we could make it even smaller, like that. Still holds up. What if we did this? 56, 28. Okay, so the big new idea for today is that the angle at the center, if you are using an arc as the base, and you could use an arc or a chord, doesn't matter. We say the arc CD subtends an angle at the center. In this case, it subtends an angle of 56, and then it subtends an angle at the circumference of 28. So let's see how we can use this in questions. So here are some circle geometry questions. And in each of these questions, you have to find an unknown. So in the first question, in question 8, you have to give me an answer. So let's do 8, 9, and 10 together. So B equals, I want you to put in the chat, what is A equal to, what is B equal to, and what is C and D equal to, based on the idea that we have just dealt with. And while we're doing that, this is the chord. It's a bit big, isn't it? So this is the, oh, these pens are massive. I think it's just because I've made it a bit big. This is the chord AC, or this is the arc AC that is creating the angles. Okay, so I agree that angle A is going to be 92 degrees. So angle A is going to be 92 degrees. What is angle B going to be? Oh, I see some of the answers are coming in already, which is fantastic. Now be careful, because remember now the one way they gave you the angle at circumference, the other one they gave you the angle at the center. So B's answer is going to be 42 degrees. Spot on. Okay. 10, I'm going to give you more time. So I want you to think through it. And what I will say is that it's helpful to think about what is the arc or the chord that subtends the angle. I think this chord is quite important, because this chord makes an angle at the center over here. And then it also makes an angle at the circumference. And that might be able to help us. Now, if you're new today, I will say that we spend quite a lot of time talking about chords and angles at the center and angles at the circumference. You may need to have a look at an earlier video. If you are feeling, because it's, see if you can get me C and D. And then those who are feeling like they're on top of the world, 11, 12, and 13 are there already. You can go ahead and do that. Okay. So if you look at D, I think the angle at the center is 88, which means the angle at the circumference, which is a bit weird, still I know the shape is weird, is 44 degrees. Now, how do I get, so if this is 44, the question is, how do I get, oh, but wait a minute. Guys, I think there's a triangle hiding inside of the circle. Isn't there a triangle hiding here? And what is the special name for these two arms of the angle? Maybe that can help you. What is angle C going to be? I want to give it a little bit more time for this, because it's quite a sneak. It's combining some of the ideas we've been talking about.
So,
Yeah.
can I just remind the learners, because it's something I remember when I was in school,
Yeah.
I always tend to forget, especially with circles, always remember that the radius, no matter where it is in the circle, is the same length.
Yep. So
And
these two are
especially-
like that.
Correct. So that's all I'm going to say. And that's something that we tend to forget about when we do Euclidean geometry, in other words, circle geometry.
Yeah, exactly. So this is so important. So I think D is a little bit sneaky, but most of you have got that because you can see the direct relationship between the angle at the center. It's like a weird, like almost kite-like shape, but the C is hiding, and it's hiding inside this triangle, which is an isosceles triangle. So what I think I would do is I'd say, well, what is 180 minus 88? And I think that leaves me with 92 degrees. But those 92 degrees need to be spread out between not just the angle C, but the angle C and, well, it's going to be this angle over here and this angle over here. And so what I need to do is go 92 divided by 2, and that is going to give me 46 degrees. Now, whilst I'm not obsessing about reasons at this stage, I do want to mention the correct reasons for these things. We're in sort of building up to lessons 7 and 8. So the reason for basically the one where D is equal to 44, the reason we use is angle at center equals twice angle at, oh, sorry guys, I need more space. So let me, and use a thinner pen. Let's make it thinner. So we go angle at center equals twice angle at, sorry, I'm doing this terribly, at circumference. Now, I think that makes sense. We don't have to memorize it yet, but just to bear that in mind. And then obviously I mentioned earlier in the lesson, we use the reason angles opposite equal sides. So we know that OB and OA are radius. And so that's how we know that these two angles are equal. But again, I'm not going to obsess. Let me leave reasons for another lesson. So I would like you guys now to try and do 11, 12, and 13. And what I want you to concentrate on is what ma'am just said is, where are they hiding? Where are their isosceles triangles hiding in the circle? And where are their angles? And what I used to get told when I was learning this is, don't be afraid to use some colors to help you. So maybe if I just do this, this might help my brain kind of unpack all this information that's hiding in this question. And what I'm trying to do is sort of show you some of these relationships that might be hiding there. But for now, I'm going to give you 4 minutes to try and finish these 3, and then we'll go from there. So, you guys, we've been working so hard today. We haven't even taken a break. Oh my goodness. But I mean, okay, we're almost at the end of the lesson. So I guess we've just been so focused. So this is a chord. We could have used the arc as well. It's not a problem. This is the angle at the center based on this chord. And so this is the angle at the circumference. And so E is going to be 49 degrees. So that is for E. Now for F, I think for angle F, I need to use the fact that this is a isosceles triangle. Now, I use up 98. So in total, the triangle has to add up to 180. So I'd love to know what it is if I take away 98. And that gives me 82. And now that 82 has to be spread between two places. It has to be spread between here and here. And so I divide it by 2. And I should get F is 41 degrees, which I think a lot of people, I'm seeing Kevin answer that. I see that. Okay, Koatiwe is already on to the next question. Susanna agrees with me. Okay, so I'm going to give a bit more time, but you should get 49 for E and 41 for F. My eyes are getting a bit sore, but I think it's because I need some light behind me. It's dark. I think. Okay. So how are we doing on 12 and 13? We're going to finish with these today, guys, because I think we want to let our brains time to digest this. And so I think in this question, this chord is quite important because it shows us the relationship, I haven't actually done proofs with you, but this is called a theorem. And the theorem says that if you have a common chord, or if you have a chord and it makes an angle at the center, and it also makes an angle at the circumference, you know about the relationship. But that angle has to be anchored on the same 2 points. So I think that angle G should be double 38, which is 76 degrees. Now, once I know what that's 76, that can help me work out what H is. I want to see more answers coming through with that in the chat. So I know I need 180 minus 76 to help me along the way. What does that give me? That gives me 104, but that's not the answer. Yeah, so again, what we need to do, I see the answers coming through nicely in the chat, is you've realized that we need to split that 104 over these 2 angles. And so we divide it by 2 and we get 52 degrees. So we have H is 52 degrees. Well done, Mark. Well done, Susanna. Well done, Guguletu. We are on our way to victory. Last question for the day. So I think what I'm going to do is I'm going to try and work out what that angle is and its relationship to the C up here. And I think that now that I'm not getting my eye in, I can see that there's a chord AB and it makes an angle at the center, but it also makes an angle at the circumference. And I know about the relationship in a circle. Now, I haven't proved it to you yet, but it's well established, like, you know, and so we know that angle AOB, or the angle at the center, I think is going to be 84 degrees. And I see that Lekonolo agrees with me. Anybody else agree with me? Well, I suppose it's on our way to get there. So we're going to get this 84. But now how do we work out what X is? Well, because these are equal radii, we know that that's X. And so I'm going to write a little equation and say 2x plus 84 is 180. Now, again, when you do a geometric argument, you put reasons in, but I'm leaving out reasons for today because I'm building up our geometric knowledge first, and I'm just sneaking little bits of the reason in. Later on, we're going to put everything in. So I take away 84 from both sides, and I get 96. And then I divide both sides by 2, and I get 48 degrees. And you guys are smashing it. Well done, everyone. Well done. That was really good. Okay, so let me sum up. So why can't you say that triangle ABC is an isosceles triangle? Good question. Well, the thing is, triangle ABC is not an isosceles because the only thing that's isosceles, oh, that's too big. This one over here is equal to this one over here because they're radii. But if you go up to here, these sides are actually, this is not going to be an isosceles. This is going to be two radiuses. So there's one R and there's one R. But there is another theorem that's going to come into play. And the question is, what do we think this angle is over here? Now, that's going to be the topic of the next lesson. But these sides are not equal. This diameter that goes through the center is made up of two radiuses. Okay? And so that isn't isosceles. But what we do know is that there's an isosceles. Let me point it out. There's an isosceles here. So what maybe you could have done is you could have said this is 42 degrees and then use the exterior angle of a triangle theorem to work out that this is 84, which is the same answer that we got from the other theorem. And so that would be quite nice. I don't mind scrolling down a bit, David, no problem. Okay, so I want to summarize, what have we learned today? So basically today, we spoke about triangles from grade 9 and 10, and we just went over some basics. And then we looked at circles, and then we looked at the triangles that are hidden within circles. And then we also looked at how sometimes we can have triangles at the center and also triangles at the circumference. Looks a bit like a hippie symbol, doesn't it? So that's the main focus. And we focused on this idea that the angle at the center is twice the angle at the circumference. Now, in the next lesson, I still need to talk more about theorems or relationships in circles that have to do with the center of a circle. And so next lesson, even though it says, I think it says cyclic quads, we're still going to only spend about half the lesson on that. And we're going to spend half the lesson still making sure we've got the main relationships that deal with the center of a circle. Now, something you might want to brush up on is also something, well, a little bit about congruency might be helpful. I will go over it a bit, but this idea that when do we know if two triangles are exactly the same? That is an idea that is helpful to have in the back of your mind. Okay, I think I want to take questions now. So if you have any unanswered questions from today or things you just want to explore, I'd love to have that. Anya, if you could also ask the students to fill in that poll, which just gives us some feedback on how the lesson was for them. It's very helpful for us as teachers to just kind of get a feel for the group. And then while that poll goes out, I'm going to take questions and Anya will take questions as well. Okay, are there hands up for audible questions? Otherwise, the chat.
Sir?
Yeah. Is there a hand? I can't see the hand up. Sorry.
David.
Oh, is it David? David, put your hand up because otherwise, if your hand goes up, you go to the top of the chat. I can't see you. Okay. All right. David, what is your do you
mind scrolling up
to there?
Yeah.
Okay.
Go on again a bit.
There. Okay, Bongiwe. No, Bongiwe, what's your question?
Sam.
Yeah.
I couldn't understand the whole concept of how do we see the isosceles triangle on the circumference.
Okay, I will hang on the line. I will do a little bit of a recap of that in a moment. I just want to see what the other two questions are about, and then I will do a little recap about how to see isosceles triangles in a circle. Susanna?
Sir, I have two questions.
Yeah.
For the concord triangle, would it always be even?
Say that again. Will the concord?
The triangle. So I said that would it always be even?
A triangle doesn't have to be even. No, it doesn't have to be even.
So how would you figure out example number 8? Let's say A was a negative number. What would B be?
Okay, an angle. Okay, an angle can only really be negative in trigonometry. It can't be negative. Well, it
I mean, not
doesn't.
negative, so I mean uneven, like odd.
Okay, if it was odd, so if A was 127, it would just be the angle over here would have a half. It would be what's that? 63.5.
Okay.
So that's no problem at all.
And another thing, sir, is number 13.
Yeah.
How would you know that Q ABO is an isosceles triangle? Would you have to prove it, or would you just know?
No, it comes from the property of a circle. So the fact that the radii of a circle.
So it's always isosceles.
Yeah, always.
Okay, thank you, sir.
Okay, Kitty Bona, and I haven't forgotten about the question before that. I'm going to come back to that now. Kitty Bona?
Sir?
Yeah.
Can you please share the link of the app that you use to explain the circle geometry?
Okay. Anya, could you just put the link to the Watobe, or not so much the app, the website? We use the website now, and the website has the links to all the old videos.
Okay, I can do that, sir, but I think she was referring to those interactive things you were using earlier. Is that correct, Katie? Or are you referring to the previous lessons?
I'm referring to the interactive thing.
Yeah.
Okay. I don't think there are. We're busy planning something at the moment to offer some extra support, but the app itself is not available in the same way as before, as I understand it. Yeah.
Oh, okay. Thank you, sir.
Now, let me just explain what I was saying about isosceles triangles. So if you have a circle, if you take two arms and you connect them like this, these two lengths have to be equal. Okay, so these two lengths have to be equal. In order for it to be a triangle, you need to connect this third side. You now have an isosceles triangle inside of this circle. Now you can do it again. What you can do now is you can have here and here. And so when you connect these 2 points, this is also going to be an isosceles triangle. Now, what do you get when you get an isosceles triangle? Well, isosceles triangles, the angles opposite the equal sides are equal. So this is going to be equal to this. And this is going to be equal to this because they're opposite equal sides. Does that help a little bit? Okay. I'm not sure if that helps the question, but I hope that it does. Anya, anything from your side before we start to finish off?
I think just again, I know we've got a couple of questions, but I think what I would suggest for the learners, so just a reminder, Wednesdays are quiz days, but if you feel like you need to brush up a bit on your old work, I'll suggest go to the Watobe site and go watch the previous videos. All the Watobe videos are also on YouTube. So if you feel like, oh, you want to brush up a bit on triangles, you can literally go on YouTube and go check triangles also. But first go to the Watobe site and see what you can get there and watch some lessons. So that's the only thing to do.
There'll be a quiz. So there's a fun formative quiz on Wednesday that helps you assess like how much of this am I remembering. And also we're thinking about trying some other stuff too to kind of give you some additional practice, but we'll tell you more about that in future. And yeah, it was nice teaching you tonight. I know that it was starting to get a bit harder now. And so some of you will feel a bit like, oh, okay, but just take some time to draw some diagrams and just think about the ideas we spoke about. And then in the next lesson, you can even have some of those questions ready to go in the chat. So Ms. Anya can respond as we go. But otherwise, I will see you on Wednesday. And thank you for attending the lesson. I wish you well for the evening. And yeah, before we say goodbye, Anya, anything from you? Or are we good to wrap up the show for tonight?
No, we're all good, sir. I'm going to stop recording now.
Perfect. Okay.